Hello students, in this video we'll discuss the logistic equation. The logistic equation has the form dp dt times 1 over p is equal to a minus bp for constants a and b. One thing we can know about the logistic equation, so note this is one simple model of population growth. What we'll do is we'll solve the logistic equation by noting that it's a separable equation. So this equation is separable. So what we can do is we can write this as dp over p times a minus bp equals dt. And so what we'll do is we will integrate both sides. In order to integrate both sides, we'll need to use partial fractions over here. So we'll do partial fractions. We'll write 1 over p times a minus bp as a constant a over p plus a constant b over a minus bp. To find what a is, we will plug in p equals 0 after multiplying by p. So we'll multiply by p, and that tells me that 1 over a minus bp is equal to a plus bp over a minus bp. And we'll plug in p equals 0. Doing so, this term will cancel out, and this will just be 1 over a, and that will tell me that a capital is 1 over a. And similarly, we can multiply by a minus bp. And that will tell me that 1 over p is equal to a, which we just found, times a minus bp over p plus b. And now what I will do is I will plug in a over b. For p. If I do that, I will get a 0 over here. This term will cancel out, and I will have 1 over a over b, which tells me that b will be b over a. Now we can go back to our original problem and write it as a over p, and we found that a was 1 over a, so I'll have 1 over a over p plus b, which we found to be b over a minus bp is dt. We can integrate both sides, and we will get a 1 over a log of p. And now we will make a u substitution over here to figure out this integral. So in this integral over here, we will let u be a minus bp, and then du will be negative b dp. And so what will happen is that this integral over here will turn into the integral. I will have a negative b dp, so that will turn into a negative du over a, all divided by u. So what I'll have over here is I'll have a negative 1 over a log of u. So we can fill that in over here. So this will be a minus 1 over a, the log of u, which we know is a minus bp, will be equal to t plus c. So I'll multiply both sides by a and write the log of p over a minus bp. is equal to AT plus C. And finally, I will take the exponential of both sides and write P over A minus BP is a constant C e to the AT. And what we have here is we have a rational expression in P is the exponential, a constant times the exponential of AT. We can solve this equation for P to write P as a function of T. And this is the solution of the logistic equation. We can also examine what happens in the case when as t goes to infinity. As t goes to infinity, we can find the limiting behavior of this expression for the population, and that expression will be the carrying capacity. We'll see further examples of how we use the logistic equation in applications in the course. Thank you very much.